What's going on, you guys? Mr. Allen here with some arc length and sector area problems. But these aren't the straightforward ones where we give you the radius and just ask you to find it. You got to work for it in these two examples here. They're a little more challenging. All right, first one. We got to calculate the sector area of a circle that has an arc length of 8.5 inches and has a central angle of 73 degrees. So let's just draw this up real quick. I'm going to draw up a circle. Got the center of that circle, right? And then I got an angle at 73 degrees. So if I was going with this, that, I think that's about like 73 degrees. Sure, looks decent. And then this would be my arc length, which we said is 8.5 inches. All right, cool. Well, I want to find the area of this sector here, right? The pizza slice, yeah? So I would need a formula for that. Now, there's a couple ways of writing this. Some people like to do it with a proportion. That's kind of my move. Others like to use just a formula that's already solved. So I'm gonna write up the proportion first here, which would be theta over, we're in degrees, so 360 equals, so this is the portion that we're talking about, 73 degrees for this one, over the whole, right? So it would be my sector area, K, over my area of the circle, pi r squared, which we could then solve all this as well. Now, here's the other thing, is we gotta have our arc length involved in this one here too, right? Because I need my radius. I don't have my radius yet. I gotta solve for my radius of this circle here, and the only information I have is with my arc length. So my arc length is the same proportion basically. So you'd have theta over 360 equals my arc length, S, over my circumference formula, 2 pi r. And let's look at these two proportions here. We have part over whole equals part over whole. Part over whole equals part, the arc length, over the whole arc length, 2 pi r. Whole arc length. Circumference. There we go. That's better. All right. Now, I've also seen them all solve for their particular ones by multiplying by your denominators here. So you could even write these formulas as K equals, let's see here, we'd have pi r squared times theta over 360. Or you could have S equals 2 pi r theta over 360. So there's a couple ways to do this, right? Up to you what you want to do with your formulas, all right? So let's go for it. Let's solve for r. I think it's easier with the proportion to solve for r because then I don't have to isolate this guy right here. So I'm going to erase some of this stuff here and rewrite it, okay? Because otherwise I'm going to run out of room. So right now I'm working with my circumference, right? So I got theta over 360, so we're going to have 73 over 360 equals my arc length of 8.5 over 2 pi r. So I got to solve for r. I'm going to cross multiply, so I'll have 73 times 2 pi r. So 73 times 2 is 146. So 146 pi r equals, then I got 360 times 8.5. So we got 3060. 3060. That's better. All righty. And then I got to just solve for r, so I'll divide by 146 pi. Cool. So divide by, make sure when you do this, 146 pi, that you put parentheses there. Otherwise, it'll divide by 146 and then multiply by pi. You don't want that. So there's my radius. So radius r equals the 6.67. 1, so on and so forth. A little bit of change there. So now I can use this to get my sector area, which I guess for this one, I'll just plug it into that formula that I had. So my sector area, it's already solved for it, is going to be the portion of my circle, 73 over 360, times my area of the whole circle, pi r, this guy, squared. I'm a big YOLO guy. You only run once, if you couldn't tell. So I'm going to use that guy right there when I plug this all in. So I'm just going to do a little fraction here because it'll look nice and pretty that way. 73 over 360 times pi times this guy. I arrowed up, squared, enter, boom. Got our answer. We are looking at 28.353. So 28.35 inches squared for my sector area of this bad boy right here. Woo! That was a doozy, man. That was a doozy. All right. Let's pop over to this one now. On to the next. We got the area of the sector. Area of a sector is 34 meters squared. So now I'm given the area with a central angle of 1.2 radians. What is the radius of this circle? I'm not going to draw a picture for this one. It's taking up a little bit of room, but let's see here. So we have the area of the sector. Let's set up a proportion here. I like the proportions for this kind of stuff. You might not. Whatever. All right. So we're in radians here. So instead of theta over 360, it's theta over 2 pi. All right, because 2 pi is equivalent to 360. So we got 1.2 over 2 pi equals, now my sector area, the portion of the whole area, is 34 over pi r squared. And now I can solve for r by doing some cross multiplication, okay? So we got, you guys hear those snowmobiles going by? They're on the river right now. They're flying down the river, super loud. It's kind of cool. So I guess 34 times 2 is going to give me what, 68 pi? Equals, and then we got 1.2 pi r squared. So our pi's are going to cancel, right? Sometimes it's nice to just keep things out of the calculator for a bit. And I can divide this by 1.2. So 68 divided by 1.2, 56.6 repeating equals r squared. And then we'll go ahead and square root both sides. I think that seems about logical, yeah? Alrighty, so raise to the 0.5 or square root. You could do that as well. You could hit second, square root, arrow up, put that guy in there. Either way is cool, right? I like to raise to the 0.5. It's less keystrokes, saves time, And I get r equals 7.527 and change. Okay. So now it wants to know, oh, that's all it was. What is the radius of the circle? Cool. It didn't ask for anything else. So 7.53 meters. If it wanted the sector area, or sorry, if it wanted the arc length, we could have done that. You would just, I can do it in the calculator real quick. We would just take our radius here times 2 times pi, and then multiply it by the 1.2 over 2 pi. Oops. Hold up. Almost broke my own rule. 2 pi. Hey, there's my arc length. All right. So, could have done it if we wanted to. But it only asked for the radius, so that's it. And I just did some bonus math because I just love the math, man. Alrighty. Hope that helps, guys. Sector area and arc length are very fun, right? I, again, like the proportions for my formulas. Not everybody does it. Some people like it solved for the arc length or solved for my sector area. And then sometimes you just got to dig through that formula a little bit. But proportions to me are the win. Up to you. See you later.